to a gradient, remember? So the change in y over the change in x. So we've now got this formula here that we need to follow. Okay, so that's how we would find the gradient of the curve at different points. So we have to remember what f of x plus h means. That means that instead of just x going inside my bracket, I'm going to have x plus h going inside my bracket. So here, wherever there's an x, I'm now going to write x plus h. So it's going to be x plus h squared. Yes, you with me?
Yeah.
Subtract x squared. Because we're doing f of x plus h minus f of x. That's then divided by h. Because we discovered that the x subtract x disappears. Right, so now we have to use our expansion laws. We've got x plus h squared. I might need two equal signs in between here. Oh, shush now. So we probably need two lines of working here. So we've got x plus h bracket x plus h. Oh, not squared. Okay, so we're using our FOIL. So we've got x squared plus xh plus xh plus h squared. Oh, we need another one actually.
I don't have space. I ran out.
I do.
Sorry.
Of course, it's not vertically.
It's not like a bird.
I like to thank you, Cameron. Yeah, I know.
Not recording.
All right. So now we need to simplify it.
Can we cancel out the x squared?
We hope that's what we're going to do. So we've got x squared here and minus x squared here, so they're going to go. And we've got xh plus xh, so what's that become? 2xh plus h squared over h. Now, that looks really messy, I'm sorry. Now, we need to simplify that if possible. Now, what can we see is in our top two terms? We've got 2xh plus h squared. So we can actually factorize it. We can bring the h to the front. So next to it, I'm going to now write h bracket 2x plus h. You all happy with that? So I factorize the top line, the numerator, and I've got h bracket 2x plus h. Because I brought h to the front, I factorized it. So if I were to expand this here, I'd have h times 2x and h times h. Yeah? And now what happens with the h? They can cancel them out because they're multiplied by something on the top. And that leaves me with just this expression here. All right, now, what did we say about h? We said it's really, really small. Yes?
Yeah.
So what we would say now, if this is getting fancy, that the gradient, we're saying it's a limit as h approaches 0. So this is fancy. It means h approaches 0. So as h gets tinier and tinier and tinier, what happens is that the value of the gradient gets closer and closer and closer to a specific expression. So what we would say now is that h is now 0. And so the limit ends up as being just 2x.
I remember this.
Good. Now that means that we can now say that the gradient, dy dx, is equal to 2x.
Why did we just roll that one down?
Yeah, so why is zero? If h was 0 from the jump, why didn't you just skip h?
And this is something that is specific about first principles. Now, the reason that we have to go through first principles with you is that occasionally, very, very, very occasionally, but it does happen, a question will say, using first principles, show that the gradient expression or the gradient function or the derivative is. And you have to go through all this process. These kinds of questions are literally just testing your algebraic skills. That's all it is, testing. Because we're going to talk about gradients and derivatives, and you're going to, if starting with the function y equals x squared, you're going to end up with this answer really, really quickly, because we're going to talk about a special rule that gets you to that answer. So the only thing about first principles is that they're checking that you can do all of this stuff here. And it's frustrating, as is talking when I'm trying to teach you something. So all it is kind of a recap of our functions work. It's just getting you to put x plus h in place of the x here, expanding stuff out, simplifying it, cancelling out, and ending up with the answer. Okay, so whilst it's a very laborious process, it is specified sometimes on occasional questions. It's only occasional, so if this is something that you're like, do you know what? I don't want to spend all my time doing that. You may risk losing a few marks on a question if it comes up. But this is just one small part of calculus. But it's key in understanding what we're actually looking at. The key here is that we're looking at the gradient function. Okay, so we're looking at how does the gradient change when it's not a straight line. And we can work out how it changes by having what we call the derivative, or the gradient function, which is this expression here, 2x. Okay, so if I wanted to know what the gradient was when x was -4, I would substitute -4 into there, and I'd know my gradient was -8. If I wanted to know what the gradient was when x is 2, I'd stick 2 into there, I'd know my gradient was 4. Okay, so that's what this expression here does. It tells us about the gradient at specific points. Okay?